G'day guys, welcome back. Find the area of a regular shape with n sides and a perimeter p. And then once you've found this generalized expression for area of this n-sided shape, then prove the following result. Prove that n tan pi on n approaches pi as n approaches infinity. Okay, so we've got two interesting questions there. Have a shot at this yourself first, and then come back when you're done. Okay, well I'm going to begin by first drawing this n-sided polygon just here. Now clearly I can't draw the whole shape, but I'll just stop here just to give us an understanding of what's going on. Now how can we find the area of this n-sided shape? Well, the game plan here will be to find the area of one of the triangles that makes up this n-sided shape like this, and multiply it by the amount of shapes that exist inside of this polygon. Okay, so to make that a little bit clearer, I'm saying that the total area of this polygon is going to be equal to the area of the triangle, which is going to be half times by BH times by the amount of triangles that exist inside this polygon just here. So in this context, what are good candidates for B? Well, B can be the base of this triangle just here, and H can be the height of this triangle, which I'll draw just here like that. Okay? Now we're not completely done. Let me actually just also define this angle here, which I will call theta like that. Okay? So now what we need to do is we need to find B and we need to find H, plug it into here, and we're done and we've got an expression for A. So let's do that. Well, if I were to draw just this part of this triangle just here, it will look like this. This is that part of the triangle. It has, don't forget, a height H. This length here will be half of this, so it will be B on 2, and this angle right here will actually be theta on 2, like this. Theta on 2. Okay, so now let's get started. What is a value for B? Well, we know that the total perimeter of this n-sided shape is P, which means that the length of one of its sides is going to be equal to P divided by n. So in other words, we can say that B is going to be equal to P divided by n, like that. Okay, so far so good. We found an expression for B, now let's find an expression for H. So to do that, we need to use trigonometry, and I'm just going to write it over here. We know that tan theta on 2 is going to be equal to opposite over adjacent, which is going to be B on 2 divided by H. And we can solve for H, and we can say that H is going to be equal to B divided by 2 tan theta on 2, like that. Okay? Now, to simplify this further, we need to solve for theta, so let's consider what that is, and let me actually write that up here. We know that theta is going to be equal to the total amount of radians that make up this shape just here, 2 pi, divided by the amount of sides that there are, which is n. So in other words, theta is going to be equal to 2 pi divided by n. Now we can substitute that into here, and we can say that h now is going to be equal to b divided by 2 tan pi on n. Notice the 2's cancel out. Okay, and that's an expression for h, and now let's plug this all into here. So we know that a is now going to be equal to a half times by b, which we know is going to be p on n, like that, and then times by h, which we know is going to be p on n, if we make that substitution for b again just here, divided by 2 tan pi on n, like that. Okay? And then we all multiply this whole thing by n, like this. Okay, so far so good. Let's play the algebra game. We notice the 2's group at the bottom, we notice the p's group on the top, and we notice there's some cancellations with the n, so we can actually write this as p squared divided by 4n tan pi on n, like this. That is the generalized expression for the area of an n-sided regular shape just here. So we've answered the first question just here. Now let's answer the more interesting second question. Notice we've been given a clue to consider the limit as n approaches infinity. So let's consider what happens to the area of our polygon as the number of sides gets larger and larger. Well, as you can imagine, as the number of sides gets larger and larger, our polygon looks more and more like a circle. So that means that the area of our shape will boil down into finding the area of a circle as n approaches infinity. Okay? And we notice that the area of a circle is going to be pi r squared, and the perimeter p is going to be equal to 2 pi r, like this. So let's first find the area using our standard pi r squared formula, and then find the area this way and equate the two and see if we get this result. Well, the area of a circle is going to be equal to pi times by r squared, where r can be written as p divided by 2 pi, and then square that just there. So in fact, you can write this as p squared divided by 4 pi, like this. That's the area of this circle with a perimeter p. Now let's equate this value to this guy as n approaches infinity. So we know that the limit as n approaches infinity of p squared over 4n tan pi on n must in fact be equal to this value, which will be p squared divided by 4 pi. And of course, you can notice some heavy cancellation. We notice the p's cancel like this. We notice the 4's cancel like this, which means that we can say that n tan pi on n must be equal to pi, like this. And so that is the answer to your second question just here. Oh, and I almost forgot the limit as n approaches infinity. There's no way you can get rid of that guy just there. Okay? And so that proves this second question just here. Now, before I finish this video, I want to show you something really neat. I've managed to plot the area of our shape versus the amount of sides that it has. So as you can see, as the number of sides increase, its area also increases. But of course, it's bounded by the area of our circle just here. Now, what's interesting about this graph just here is the evidence shows that the triangle, right, which is sides 3, has the lowest possible area to perimeter squared ratio out of all the regular shapes in existence. And the circle has the very highest area to perimeter squared ratio out of all the regular shapes in existence as well. And I thought that was pretty cool and worth mentioning. Anyway, guys, I hope you really enjoyed that video. Just so you know, I also do videos in engineering dynamics, vibrations, and statics, so check them out on my website too if you like. Cheers.